Welcome back to freehighschooleducation.com. Today we are going to do an exercise session for chapter 6.1 on page 203. We are going to do the red colored exercises. Simplify, assume that all exponents are positive integers. We'll start with number 31, x raised to a times x raised to b. Here we apply the rule. We have two numbers, they have the same base, and they are multiplied by each other. Each one has a power. We simply add the powers. Now, a mistake made by the previous owner of this book is as such. He answered this way. This is a wrong answer. This would be the answer to a situation like this. Here in this situation, we have a power raised to a power. We multiply the powers. But when the powers are multiplied by each other, as in this situation, we add the powers. Number 32. Again, the same base, and we have powers here. This is 1n, so we add the powers, and that will be y, the same base, 1n plus 4n, that's 5n. Number 33. We apply the same rule, same base, and each one has its power, so we add the powers. And the answer will be, and we add x plus 2, add it to x minus 3, and that will be 2x minus 1. So the power here will be 2x minus 1. Number 34. Here, the question says, find the value of n that makes each sentence true. In this case, we have to solve this part of the equation. And here we have two numbers multiplied by each other, the same base again, and we have each one has its own power. So we add these powers. We're going to do this addition here. And that gives us 4n. So the answer to this multiplication is x raised to 4n, and that's equal to x raised to 12. If these two numbers are going to be equal, and since they have the same base, then these two powers must be equal. So 4n must equal 12, and so n equals to 3. Divide both sides by 4. Number 35. Raised to 5n minus 2 times y raised to minus 3n plus 4 equals to y raised to 8. Here, we are going to do this multiplication, and that will give us y. We add the powers. Five n minus 3n, that's 2n. And 4 minus 2, that's plus 2. So the answer to this multiplication will be y raised to 2n plus 2, and that's equal to y raised to 8. As in the previous example, if these two numbers are going to be equal, and since they have the same base, then the powers must be equal. So 2n plus 2 equals 8, and 2n will equal to 6. Take 2 to the other side and change the sign. Divide by 2, and n will equal to 3. Number 36. So the first power is 4n minus 1, the second power n plus 2, and that's 6n minus 5. We are going to do this multiplication, and that will give us c. We add the powers, 4n minus 1 plus n plus 2, and that gives us 4n and n, that's 5n plus 1. And that's equal to c raised to 6n minus 5. Again, these powers must be equal, so 5n plus 1 equals to 6n minus 5, and we solve this equation. We can get 5 to this side, so we have 5 plus 1 equals 2. We take the 5n to the other side, and we get 6n minus 5n, and we have here 6 equals to n. And this is the answer, and with this we come to the end of this session, and we hope to see you again.